Welcome to Monday. This is the study guide which I'll send out today. This is chapter 7 study guide. And notice you have 3 different sections on the test. So we have a non-calculator section, a calculator section, and an honor section. And so if you go back through your homework, you should see these instructions right here, almost word for word. Like in 7.1, it says solve the system by the method of substitution. Guess what? If you go back to your 7.1 homework, and you go look at the instructions, you might just find something exactly like that. We good? All right, this is also from 7.1, something about rectangle and finding dimensions of it. And then we kept on moving on. So 7.2, 7.3, and then 7.5. That's where we're at there. And then you will need a calculator for this test. For Canon students, you'll need it for 3 problems here. Using graphing utility to solve a system and then solve a system inequalities. And then honor section application problem, and then some extended honors problem, which I'll try to figure out how to make up. It'll be fun, super fun. For me, at least for me. Okay, with that said, let's jump to a blank slide here. I guess I should do it this way here. Okay, so you guys talked to me about how 7.5 was okay, or no? 7.3, yeah, 7.3 was the bear, huh? Yeah. So let's go through any questions you guys have. Let's do this as a homework question day. Let me list them, and then we'll keep on going. And if not, then I'll put some problems for us to try today. So this guy goes down. All yours here. 7.1, 7.2, 7.3, or 7.5. Seven 7.3. Sorry, say that again, Maddie.
27. I have questions about 21 and 23 from
21 and 23. Yeah, right there. Ooh, okay. And 53 from the same section. Awesome. Okay, guys. Huh, you guys did not choose number 1.
What was number 1?
It just says determine whether the ordered pair is a solution or not.
Yeah.
Let's go 7.3. Let's go. All right, going in order. Actually, no, let me do it on the next slide here. 7.3.21 is what I want to do. All right, let me write down the problem here and we'll jam. I think it'll take us all this time just to do those here. Zero, 7x minus 1 plus 3 is equal to 0. Dunk, 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 dunk. Okay. 21. Just want to see how that works. Okay. Let's begin. Let's begin. All right, you guys tell me if I'm going too fast. Otherwise, we'll keep on going here. So notice on this one, there's none of them. There's none that actually can get x with the exponent of coefficient of 1 in front of it. That is no fun. So we're stuck dealing with multipliers of things and still kind of working through this whole process. So at this point, just choose. If there was a way to get a coefficient of 1, we would definitely put that to the top of coefficient of x. I can keep it like that. I can move it around. I think I'm going to keep them like this. We're good? So now the question is this: what should I multiply? Sorry, real quick here. So I'm going to keep it like this. Therefore, this guy comes down like this. No change to this one. I'm going to keep it just like that. Done. We're good. So I'm going to create a new equation 2 and a new equation 3. So first things first, what should I do to cancel off the x's for equation 2?
And isolate x,
Talk to me.
add 2y plus 3z to the other side, and then divide it by 5.
Oh, gotcha. Okay, the problem is you're going to isolate one equation, but 3 different variables still. So here's what I would do. I'd multiply this top equation by 5 to give me a 15x. I'll multiply the bottom equation by a -3. That gets me a -15x. For starters, right? We're going to add them up. We're going to cancel out the x's, and that'll be our new equation 2. That's what we want to do. Okay, so let's multiply every single thing here by 5. So this becomes -25y plus a 25z is equal to 5. Bottom equation by -3, so that makes -12. This makes plus 6y. That's cool. Minus 9z is equal to 0. Dun, 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 and adding. X's are gone as planned. We're doing great. What do we have here? Is it -19y? Is that right? -19y. What is this one?
16z.
Plus 16z is equal to 5. Can I reduce that any? No, that's just not very nice. Okay, so that just became our new equation 2. So -19y plus 16z gives us 5. Okay, so now we're going to do the same thing, and this is the way I'm going to do it. I'm going to go like this. I'm going to go this way down and this way down. Now we got to create a new equation 2. Okay, does that help as far as the flow goes, right? Flow goes up, take care of the first 2 equations by creating a new second equation. Flow down, still the top equation, the bottom equation, but this time we're going to get rid of the x. So multiply the top by 7, the bottom by -3. Would that do it? Yeah, because this one becomes a positive 21x. This becomes a -21x as planned. This is good. Okay, let's keep on going here. So -35y plus 35z is equal to 7. On the bottom, multiply by -3 each time. So positive 3y minus 9z equal to 0. Let's add these guys up. And did we accomplish our mini goal? Did we get rid of x? Yes, gone. Okay, help me out with the rest.
-32y.
-32y.
Plus that would be 26z.
Okay. Okay. Are we good there so far? And gotta keep on checking our multiplication each time. Okay, now can I reduce this equation? Like, are all of them even numbers that I can kind of divide through by 2? No. That is no fun. That is seriously no fun. Okay, so let's bring this guy in. This is -32y plus 26z is equal to 7. Oh, and are we still doing good?
Yeah.
Awesome. Big numbers ahead of us because these guys did not reduce at all. Okay, so top equation is done. Next is going to be the bottom equation. So top equation, we're going to rewrite it as is, no change whatsoever. This is 3x minus 5y plus 5z is equal to 1. So this comes down now, and this one comes down as well. Or we can switch them around, but again, you can switch them or keep them, whichever way you like. So negative 19 plus 16z is equal to 5. Okay, good there? So now the first two equations come down. Our job is to get rid of or change up the third equation. So here it is, what we're gonna do. We're gonna go like this and like this. Oh, huge numbers here. So grab your calculators if need be. What should I multiply by in order to get rid of the y values?
You can multiply the top one by -32 and the bottom one by 19.
Yep, perfect. One of them has to be a negative sign, one has to be positive. So Landon said positive 32 on top.
Sure.
Negative, is that what you said or no?
I said the opposite of
Okay.
-32 positive,
Sorry.
but either works.
Okay. All right, now have to help me out with some calculators here. So what is negative 19 times 32? 608. Okay. 16 times 32. And 32 times 5. 160. Okay. On the bottom, let's see, negative 32 times a negative 19. Let me guess, it's gonna be 608. Whew, that was quick. That was done all in my head. That was awesome. I can multiply really, really fast. 26 times negative 19. 494. Okay. And 7 times negative 19. 140 minus 7, 133. Yes. Awesome. Negative 133. And we're going to add them up. The y's cancel as we planned. So let's see what happens here. 512 minus 494. 18, see? 27? Yeah. Okay, can I reduce that somehow?
Yeah.
By how much?
Divide both sides by 9.
Divide both sides by 9. So this divided by 9, that divided by 9, we get what? Z equals, oh no, 2z, right?
2z equals 3, yeah.
Equals 3, okay. Uh-huh. Perfect. Okay, so we got first equation stayed, second equation modified, third equation's almost solved. Not quite. Perfect. Now we go up the ladder here. If that's true, then z is equal to 3/2. Boom, done. If that's true, then we go on to the next one. Negative 19y plus 16 times 3/2 is equal to 5. Now let's solve for this one. Two, oh, that's cool. 2 and 16 will reduce, is that right? Are we okay with 24, is that right? Awesome. Owen?
It's y is 1.
Why is 1? No, you're cool. Just checking. Y is 1. Everybody good there? Sweet. Okay, now we know z and we also know y. So now let's plug it into the top equation. So notice we're just kind of, we're plugging in stuff because we only have one variable left to solve for. And of course, it has to be a fraction. Seriously? So 3x minus 5 plus what, 15/2 is equal to 1. You guys talk to me here. How would you guys solve this? I would multiply everything by 2. That's just me. All right, what would you guys do? Okay, that's cool. All right, multiply by 2 both sides. Annette got the memo. Let's say what the teacher's gonna do. Oh, great. Okay, everybody good there? Just got rid of all my fractions. Dun, da, da, da. Now I can deal with the rest of it. Notice the 15 did not change because that's when the 2 canceled. But each one of those just got twice as big. That's all. So 3 times 2 makes 6. 2 times -5 made -10. The 2's canceled, and then 2 times 1 on that side. Oh, now this can be put together. -10 and 15, that's easy. That's just a nice 5. What is that, a -3? Divide by 6, divide by 6, and x is equal to? My little answer sheets here. -1/2, okay, I'll go with that. Just use this. Boom, okay, I checked with Bob, he agrees with me. I love when Bob agrees with me. There it is, boom, we're good? Okay, now let's, say again? Yes, Okay, x goes first always, so -1/2, then the y follows, and then we have ourselves a 3/2. Or you could write 1 and 1/2 is fine. Either one of those would be just perfectly fine. But always x, y, then z. Done. Okay, I have the sneaky suspicion we'll be here a long time. 21 off the list. 23 is next. Okay, 21 is good, everybody? Nice. 7.3, 23. Let's jam. So this is x plus 2y minus 7z is equal to -4. 2x plus y plus z is equal to 13. 3x plus 9y minus 36z is equal to -33. Bigger numbers at the end. Okay. So first things first, our pop in the brain is, do we have x with the coefficient of 1 on the top equation? Yes. Oh, it makes it a lot easier now. So this guy is going to stay exactly the same, no change whatsoever, like it very much. So how does that help us with the coefficient of 1? Is the multiplier only going to be one time for us? We don't have to multiply both top and bottom. Okay, so let's go with it here. I get to pick on people now. So Isabel, which one should we multiply and by how much?
I will do the first one by -2.
Yes, Once you have this coefficient of 1 right here, we're just going to keep multiplying those guys to create opposites. In this case, it'll be multiplying through by -2. So -2x minus 4y plus 14z is equal to 8. You guys watch my multiplication? This one, I just have to rewrite it exactly the same without any mistakes. That's the trouble there. Because sometimes we can even have mistakes rewriting stuff, huh? Like, where did that 3 come from? I was rewriting a test for the calculus class. Instead of 15, I had 15 on the page when I wrote it out, but I made it 13 when I put it on the word problem, and it made it so much more difficult. And I was like, yeah, I made it more difficult. That's good.
Don't do that on my test, please.
Okay.
Write your numbers down correct.
So -3y, everybody good there? Plus, 15z. I think we got some good stuff here. Look at this. Can I reduce this guy down before putting it in? Yes, okay, so before making it into the second equation underneath, We're gonna divide everything through by negative. Perfect, yeah, -3 is way, way better. So let's divide this by -3, -3, -3. Instead of writing it over here, then writing it again, can we just write it in? A net, just to bug you here. What would be the equation right over here then?
Y equals,
Well, y would be
that's not y equals.
minus,
Y minus,
15 divided by 3.
oh, sorry, 5.
5,
5
perfect.
equals 7.
There's perfecto. That's awesome. Good job. Okay, there it is. Awesomeness. Landon. Da, 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 da. I'm going to go down now. The curl goes down. Dylan.
That one we did get right there. How did we get the thing on the bottom?
We divide it. It's this guy going right over here.
Gotcha.
And we reduced the equation. We did a reduced form of the equation. Or we did equivalent equations to come down. Okay, da, 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 da. Landon, all yours.
I would say multiply the top by -3.
Perfecto. You guys are getting whiz kids to do like this here. So I'm going to go -3x minus 6y plus 21z. You guys check my multiplication table. I might make a mistake just for the fun of it. That's called teacher speak. Like, I'm afraid I'm going to make a mistake. I'm going to blame you for it. That's all. Okay, da, 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 da. Dylan, all yours here. You tell me what is going to be our equation underneath.
Will be 3y minus 15z equals -21.
Okay.
No, it's like the same thing. It's
Oh, that is weird.
Inverse of that.
Okay, hold on. So let's do this here. Let's, can we divide out the 3?
Yeah, so it'll just be y minus 5z equals -7.
Oh, interesting. Y minus 5z is equal to -7. No
Isn't there a rule
way.
about that? And if that happens, then it's like,
Uh-huh.
what would that mean again?
What
I
was
figured out why I
that
got it wrong on the homework.
thing? Okay,
I wrote I was using a 4 instead of a 9.
gotcha. Okay. Did you like copy down the problem itself incorrectly?
Yeah,
Okay.
I was wondering why I just kept on going.
Okay, so here's our problem. I have two equations that are exactly the same. So they're going to produce for me the exact same answer, right? So we don't need both of them. So when we rewrite this, let's write on the next page here. It'll be x plus 2y minus 7z is equal to -4. And we'll see if they use the a value again, just so you guys, yep, they use the a value again. Okay. So this means we actually have infinitely. Sorry, Owen, go ahead.
Is A where you solve for one variable and then to another?
So we are going to have a relationship, but the relationship is not like all the values in space. Hold on, let me have the truck pass. Thank you. It's not like infinitely many solutions, like all the solutions in space, right? It's a specific infinitely many solutions. So it is, like, remember how we talked about, it's the wall on the side of the room and the ceiling connecting it. And it's this line that will protrude all the way from the end of the class to the beginning. It's like this line, right? That's the infinitely many solutions. Okay, how do we do this here? Since we lost our z value, right? There's no third equation. We say this, okay? We're going to say, okay, the relationship that I'm going to create is z is equal to a. That's my relationship.
What's the reasoning for doing that?
So a could be whatever you want. So let's say a line is in space like this right here, right? Along our wall, right? So once the a value is defined, then I get this point. Let's say A is equal to 3. So that's the point that's connected in three-dimensional
But why
space.
can't Z just be whatever?
You're because A is going to be a counter for us eventually. So A is equal to 0, 1, 2, 3, 4, and it creates this little line.
Z technically is whatever because it's whatever you plug in for A, right?
Mhm.
Z is equal to A. And A
Yeah.
can be anything that you, any number. You
A is defined to be any integer as opposed to a variable because Z is still a variable. A now becomes a constant.
So we're not replacing Z with another variable, we're replacing Z with any integer basically.
Yeah, and that we do that by just saying A. That's cool. Okay, guys, real quick here. Three-dimensional space, the way we draw it really in math class is we draw this little guy coming straight up. And then what we do is we just angle this out just a little bit here. And then we make this guy go like this. Does that look like a three-dimensional sort of space? I think I like that. And so my daughter, she's taking three-dimensional calculus right now. So she has to actually draw this in three-dimensional space. Let's say it's not a line, but let's say it's a curve. So she has to draw like, okay, that point here goes like this, and it'll end up here. It's a flow of wind or something in a vacuum. We can actually do it with our fingers as well. If you guys go like this, with the thumb being straight up, your index finger pointing this way, and the middle finger, just bend it to go inside, right? And so we say, there's your three-dimensional axes, right? So side here, and then make that little turn. And then, so because our middle finger and our thumb is away from each other, right? You just think either bring the middle finger back to where the thumb is, or you bring the thumb forward to where the fingers start, right? And then you just, usually it's in your mind, you bring the thumb forward. And so you have this three-dimensional space that we think of, kind of fun little things. It's kind of like multiplying by nines with your fingers. Who knows how to multiply by nines with their fingers? Yeah, that's cool stuff.
If he's asking this probably exists.
Okay, so let's do this here. So is Z is A, good. Then we go like this. Then we say Y is going to be defined by this equation. So how about we subtract or we add 5 to both sides?
How do we know that we can't solve anything past this point?
Because one of our equations disappeared on us. So now we have 3 variables, but only 2 equations to deal with.
And when it's that scenario, then you can't solve for it?
Correct, yeah, there won't be a specific or one specific value that does it. So we say one variable is subsumed into another variable. That's our problem. Okay, I got this relationship now, dun, dun, dun. And now the big relationship. Here we go, x plus 2 times 5a minus 7 minus z, I'm sorry, minus 7a is equal to -4. Can you solve for x? Let's see, add 14 to both sides. That would make a 10, I believe, is that right? And then x becomes -3a plus 10. Okay, that's my last one then. Okay, so now I'm gonna keep that over here. My relationship now is x goes first, followed by the y value, followed by the z value relationship. Done. And so this guy right here, because it's goes connections between them, this will become a line in three-dimensional space. We good? So that means, let me erase this little piece right here. Do-do-do-do. That means it's kind of like a line like this, just kind of flowing three-dimensional space. But really what this means is we have three sheets of paper. We have three planes that are coming at each other like this. Yeah. So it's a very, very specific piece. It's like sheets of paper all intersecting the straight line. If you were to take a cross section of it, it'll look like this. And there's our line right there. If you're to look from here. I don't know. I draw an eyeball. I don't know. But if you're to look from here at it. Oh, like this. I don't know. There you go. There's my fun guy. Okay. Gotta give him a name sometime. Say again?
Frederick.
Frederick, okay. Frederick, okay. Jamming, let's see, we got 5 minutes left here. We just did 2 problems in this time. Okay. They do. Let's go with the next one. Let's just jam here and we'll finish up the rest on Wednesday here. So 27, I think we can finish up 27 real easy. 7.3, 27 on our hands right now. I'm gonna go a little bit faster. Those I did want to do slow just for us to get into the rhythm of doing them. And these guys are the difficult ones here. So notice this one is already set up. Whoa.
This is the one where we did the like 30 minutes of work and didn't even get something close.
Oh, really? Oh, I'm so sorry.
I even got down to like the final answer with like whole numbers.
Oh,
So
wow.
usually when you get whole numbers, you're like, oh, I assume I did the problem right. And then the back of the book is like have some fractions. So apparently I didn't do it right.
I used sliders. I did not figure this one out, and I couldn't even figure out what slider did. I was just staring at it for so long, trying to figure out what they did.
This problem's on the test, I'm just gonna-
It's gonna die.
I could do that. I was just gonna skip it.
Let's see if I can do. Okay.
Now it's sticking to the tire.
So real quick here, let's go. We're gonna burst Owen's bubble just a little bit here. Notice we have this situation here.
You use A, right?
Yeah, so A is gonna be used here, but before we get there,
4x equals z.
say again.
And you do 4x equals z to start.
Oh, yeah, you could do that.
Yeah, just kind of looking back at the book here. Let me go with if z is equal to A, that means that 1/4 A, right? And if that's the case, let me see how they want it. Okay, yeah.
You could do 1/4 A minus 2y plus 5a, 3a equals.
1/4 A minus 2y plus 5a is equal to 2, is that right?
Yeah.
Let's see, with time remaining here, let's multiply everything by 4. Is that okay if we multiply everything by 4?
Yeah.
That makes A minus 8y plus 20a is equal to 8. You guys talk to me here. Make sure we're doing our work correctly here. That becomes 21A is equal to 8. And that becomes minus 21A plus 8, which divided by negative 8. Ooh, this is not very nice. Not very nice. It'll be 21/8 A. Oh, that's interesting. It's minus 1, is that true?
Okay, so that's what we had for Y. In the back of the book said something different.
That is no fun. Okay, so I have these three right here.
Sliders are something as well.
Then you go back to the back of the book and like, what? It's 2A.
Yep, that's
It's
what the back of the book said.
21A minus 2
Okay, so we were right. Wow.
and 8A. That's what it says for the
None of
answer.
that looks correct. Oh,
Ah.
did they multiply everything to make it?
I
They
think
did.
so.
That's dumb. They multiplied everything by what?
Let's see. Is that 8 on this side here though? Just want to make sure that's 8.
Wait, but if you multiplied 21/8A minus 1 by 8,
So actually, everything we have
Minus
is correct,
8,
it's
not
just
minus
not
2.
multiplied by a thing.
yeah. Do you have to simplify it like that?
No.
No? Oh, okay.
So this would have been the correct answer just fine.
Okay, so that's what we put. And back to the book. No.
So what they did, they made everything 8 times bigger. So notice that the Z
Oh.
right
Wait,
here,
but
it's,
that doesn't, for the Y value, wouldn't that become
Yeah, that's
21A minus
That's
8
where I was
yeah,
confused.
instead of 21A minus?
So 8A, are we okay with everything 8 times bigger? No? They made a boo-boo. This right here should have been a 1, not a 2. As only, because that's the only way you can make, sorry, no, this should have been a, not a 1, it should have been an 8, is that right?
Yeah.
Because if you're multiplying everything by 8,
That's what threw me off.
Yeah,
I was
so
like,
this should have been
oh, you just
8 right here.
multiply it?
Minus 8.
No.
And so then where did you get where did that X value come from if we said it was 1/4 of A up there?
Well, because everything multiplied by 8, wouldn't it then be?
Is it just because we multiplied everything by 8?
yeah, So we've made a new A called 8 times the A, 8 times the previous 8. So yeah, so this is, and it's the A, sorry, Owen, no, sorry, they had it correct, Sorry, guys, let's go back. So, in the time remaining, so the A is actually 8 times bigger. That's the only thing that's 8 times bigger. We're good?
Why did
So-
the 1 get bigger?
Because it's not so much as everything is multiplied by 8, it's the fact that this guy here grew 8 times, but that's about it. So this guy became 8A. This guy here becomes 8A, right? Times 1/4, which is 2A. Are we good there? So this one right here, this grew by 8A. So now the 8s are canceled. We good there? It becomes 21A minus 1 still, right? It's the A that becomes bigger, not a
The book
multiplier.
said
of it.
21A minus 2.
Now they are wrong. Okay,
Uh,
so it should have been just a 1 right here, as the relationship stands. Okay, with that, we're out of time today, so we're done. We'll do the rest of them on Wednesday. And study guide goes out to you guys today.
Should we still do 7.5 homework?
Yes, please do, yeah, and come with homework questions on 7.5 homework.